25 million people in the United States have asthma. That's equivalent to 1 in every 12 people, and this number is rising every year. Half of all people who have asthma had an asthma attack in 2008. Again, that's 12 million people who had at least one serious asthma attack in a year, but many of these attacks could have been prevented. $56 billion is spent on asthma or consequences related to asthma, and it's spent through medical costs, early deaths and associated costs, and days taken away from work. So what is an asthma attack? It's a bronchospasm, or a tightening of the muscles around the airways. During an asthma attack, the lining of the airways becomes swollen or inflamed, and thicker mucus, more thick than usual, is produced. Some early warning signs of asthma are frequent cough, reduced peak flow meter readings, losing breath easily or shortness of breath, feeling very tired or weak when exercising, wheezing or coughing during or after exercise, decreased lung function as measured on a peak flow meter, or signs of a cold or allergies.
The goal of treatments for asthma are to prevent symptoms, minimize morbidity from acute episodes, and prevent functional and psychological morbidity to provide a healthy or near-healthy lifestyle appropriate to the age of the individual. This includes allowing the individual to exercise. Some current treatment options are quick relief, which are to relieve acute asthma exacerbations and to prevent exercise-induced bronchoconstriction (EIB) symptoms. These include short-acting beta agonists, anticholinergics, and systemic corticosteroids. There are also long-term options, which include inhaled corticosteroids, long-acting beta agonists, long-acting anticholinergics, combination inhaled corticosteroids and long-acting beta agonists, methylxanthines, and leukotriene receptor agonists. There are currently very few ways to predict the occurrence of an asthma attack in order to take preventative measures before an attack happens. Given that asthma is such a prevalent medical problem, being able to monitor and predict asthma attacks before they occur would save individuals and the medical industry time, money, and lives.
Forced expiratory volume in 1 second VEF1 and nitric oxide NO levels. These manage symptoms but do not notify the user before an asthmatic attack occurs. One product, PF100 Asthma Monitor from Microlife, is a digital measuring device of peak expiratory flow and forced expiratory volume in 1 second. It is battery driven, measures a range of 500 to 900 liters per minute, and includes ranges that determine severity of lung function. And these ranges can be manually set. The NIOX MNO Asthma Inflammation Monitor from Aerocrine uses infrared communication to transfer data to PC. It takes less than 2 minutes to get a reading and is pre-calibrated for nitric oxide sensor or 100 to 300 measurements. It includes a built-in flow regulator, which makes it easy to keep constant flow rate, and inhaled and exhaled through the device for accurate readings. A third device, the VitalGraph Asthma 1 electronic asthma monitor from Medical Devices Depot, is a nitric oxide test system intended to measure fractional exhaled nitric oxide in parts per billion. The patient exhales at 500 milliliters per second into a mouthpiece using the NO breath flow sample system connected to the instrument until a reading is displayed. It has a concentration range of 5 to 300 parts per billion, and its detection principle is an electrochemical sensor. 12 seconds per breath test time is for adults and 10 seconds for children.
The signs of an attack cannot be determined until the onset of an asthma attack. One hypothesis is the asthmatic hypothesis, which states that dehydration of the airways generated by insensitive water loss by the respiratory tract, stimulated by inhaling dry air during exercise, increases the osmolarity of the periciliary liquids. This releases chemical mediators such as histamine, which increase the contraction of the bronchial striate musculature, causing obstruction. Because this response is indicative of an asthma attack, we are going to look into creating a device that will measure the levels of histamine in the body during exercise that will detect an onset of the attack before it actually occurs. In order to do so, we had to come up with a list of wants and constraints. Our first constraint is safety. Our metric for this is no irritation. Our target value is pass, and our reference is ISO 10993. Our second constraint is also safety, but this metric is basic medical electrical safety and performance. Our target value is pass. Our reference for this is the IEC 60601-1 and the 2005 AMDI 2012. Our last constraint is accuracy and calibration. Our metric for this is histamine levels in the blood. Our target value is concentration in blood. Our reference value for this is ISO 5725 accuracy.
Our first one is speed. Our metric for this is can give results fast, and our target value is continuous during exercise. Our reference is ISO 11073, Health Informatics Personal Health Device Communication. Our second one is ease of use. Our metric, ease of use, and our target value is 3 or less buttons to press to get to results. And our reference is comparable to other wrist monitoring devices such as Fitbit or Apple Watch. Our third one is portable. Our metric, lightweight, and our target value is 441 grams or less, which is comparable to other wrist monitoring devices. Our last one is durable. Our metric is time, and our reference value is 1 year, which is comparable to other wrist monitoring devices.
It has been shown through studies that increased histamine levels can be indicative of asthma attacks. Histamines are contractile molecules that cause the airways to contract during an asthma attack. Therefore, there are increased levels of histamines in a person's lungs, airways, and body immediately before and during an asthma attack. By finding a way to measure and regulate levels of histamine in the body, it may be possible to sense the onset of an asthma attack before the attack actually happens. Our device is a combination of an inhaler-like device and a light sensor worn around the wrist, like Fitbits, that use optical sensors to sense the levels of histamine in a user's blood. Our device begins with an inhaler-like device that injects nanoparticles into the lungs in the form of an aerosol. The nanoparticles are phosphorescent particles containing a platinum porphyrin dye and coupled with diamine oxidase, and they react with histamines to form hydrogen peroxide and other metabolites. These reaction byproducts will then emit a glow that can be measured by optical sensors. In order to keep the nanoparticles located in the lungs where the histamine spike will be occurring, the nanoparticles will be bound to albuterol, which is the chemical in common inhalers that binds inhaler medication to the inner surface of the lungs and keeps the medication in the lungs. Once our nanoparticles are inhaled, they will bind to the inner walls of the lungs via albuterol. Then the nanoparticles will react with histamine in the lungs and airway, forming the reaction byproducts. These reaction byproducts will then be absorbed into the blood and circulate throughout the body, eventually making it to the wrist. Once the byproducts of the histamine reaction reach the wrist, our optical wrist device will detect the glow of the byproducts and, through that, be able to estimate the amount of histamine in the body. Our device will then take repeated measures of glow in the blood every few seconds in order to see when spikes in histamine levels increase. Any drastic increase in histamine levels will be indicative of the onset of an asthma attack.